Good morning, everyone. All right, we have here Amanda, Dylan, Joseph, Justin, Kemp, Rachel, Tristan, Yusuf. Good morning. Thank you for being here. Thank you for wake up early with me to take the class. All right. So today we are going to discuss unit number 2. I have a few questions from you guys. I will be working with your questions after we finish our class for today. I hope I don't take too much time on these examples. Okay, so let's jump right to the class. And the first thing that I want to mention here is that if there is a unit that you don't want to miss, is there a unit that you need to watch? The video lecture is unit number 2. Unit number 2 is fundamental for our class. We are going to be working throughout the entire semester with functions, all right? And we are going to explore the different properties of functions. Hence, unit number 2 is going to give you the library of functions. Like that is going to be like the most common functions that you are going to see in an entire math academic career. And we are going to see, or we are going to study their properties and transformations and how can we use them, right? So unit number 2, it is a must. It's something that you need to complete 100%. This is the guided note for unit number 2. You need to have everything here. You will see that on the guided note, the first table that you are seeing is the library of parent functions, right? Tomorrow is the due date for the video lecture of unit number 2. So I expect that by tomorrow everyone has this complete, right? Today what I'm going to do is to show you how to solve a few examples in Alex, okay? But it would be okay if you are not caught up with what I'm going to do in today's class, because I just showing you, or I'm giving you examples so you know what to expect from unit number 2, okay? There's a lot of property here that you need to know to complete or to be successful in our class. All right, and let's just start with the first one just to show you what you are going to do. All right, so when we are dealing with parent functions, from parent function, what we are going to know is going to be the name, so absolute value function, the equation, and the shape. You are going to see that the equation and the shape of that particular function, or the graph of that function, is going to be unique, right? So you will see that the equation for an absolute function is going to be this one. And the shape, we could say V shape, something that we use just to identify the graph, or the shape of the graph of that function. Then you will determine the domain and the range. For this one, since we have arrow here and arrow here, left and right, that means that this graph continue to the infinite to both sides, left and right. It means that the domain is all the real numbers, or from negative infinity to positive infinity. That's the domain. Range, in the other hand, you will see that this graph starts here with that solid dot, meaning, and range is all the y values from bottom to the top. So the left boundary of the range is 0, and then this arrow both continue up. Okay, We know that they are going left and right, but if we are just focusing on the vertical movement, both continues to the same place, up, so from 0 to positive infinity. And lastly are the key points, and this is going to be the most important aspect, because if we are going to be dealing with transformations, and we are going to do our transformation based on the key points, how anything on the equation of that function affects the key points. Okay, and the key points, you are going to have 3 or 2. You are going to have 3 or 2 key points for each function, depending on the shape. For example, here, if we have a V shape, you will need to have 3 key points, and those key points are here: -1, +1, 0, 0, 1, and 1. Okay. This shape, we need 3 key points to do this shape. For this one, 3 key points as well. This one, 3. A line, to draw a line, we only need 2 key points. Okay. A constant function, just 1 point. The identity function, also 2 key points. Reciprocal function, here I think it will be between I will say between 4 and 6. All right, so that's the first table. Yusuf, it is on the guided notes. This paper is on the guided notes. This is guided note for unit number 2. If you haven't bought, or your guided note haven't been delivered to your home address, this is the collaborative text. You can go to Blackboard, and in Blackboard, unit number 2 and unit 1 and 2 guided notes are available to download on Blackboard. Okay? If you need me to show you where they are, just let me know to go and show that. Okay, next table will be transformation of the parent functions, and we have different type of transformations. And again, this is something that you need to know. You need to know what are the effects of modifying the equation of the graph, and what will be the effect on the graph when we do that. Okay. We have 2 main types of transformation: vertical and horizontal. Vertical is related to all the y values. Horizontal are related to all x values. And then we have other categories where we have a vertical shift, horizontal shift, vertical stress or compression, horizontal stress or compression. We have reflection about the x-axis or the y-axis. Okay, so all this you need to know. So we have today, tomorrow, and Friday. Before this weekend, I want you to get everything, all the information from here, and start working with this, because you will see that you will get back to these 2 tables a lot during the entire semester. All right. Okay, and then on the workshop today, you will see that we are going to start practicing, and we are going to start using that information that we get from the lecture videos, okay, on exercises before doing the homework. Okay, see here that you need to be able to identify. You need to be able to identify the name and the equation of the functions just by looking at the shapes of the graph. Okay, for example, we were working with the absolute value. So you need to know that this one is absolute value function, and also that its equation is absolute value of x. Here we have a matching exercise where we need to identify, this is the parent function that we are working here, g of x. Okay, and if you can see down here, there are few modifications on g of x. Okay, and you need to be able to identify what is the effect of this -2 plus 2 on g of x. You have a reference point, which is the origin. You are going to use that point as a reference point, because if you compare all these images with that reference point, you will see that this graph had changed. Here it seemed to be a little bit to the left. Here it seemed to be up, so left, up. Here you see that it is down a little bit, and here it seems to be go to the right. Okay, so left, up, down, right. You need to know which of these modifications have those effects, and then you need to match. Here you can see that we have a function q of x. The first thing that for every function, when we need to identify the transformations, is that we need to identify the parent function. Going back to the guided notes, there's a library of parent functions. Those parent functions have one particular or something that is unique on their equation that will determine the type of function that it is. In this one, we are seeing that we have x squared. That makes this function a quadratic function or a parabola function. Hence, the parent function of q of x, the parent is x squared. All right, so we have a quadratic function here, or a parabola function, or a square function. Okay? There are many names to identify this function. Then, to identify the transformations, are going to be the differences. Differences. Let me just check if that's spelled correctly. Yeah. So you need to identify the differences between the parent function and q of x. Okay, so differences between f of x, which is the parent function, and q of x. I will highlight those differences. As you can see, q of x has a factor of 1/2 in front of x squared, and also has a +1 a second term there. Those are the differences, and then you need to be able to identify what is the effect of those differences, okay, in the graph, how they change the graph. So after you do that, the transformation will have some mathematical effects on the coordinates, on the 3 key points. Remember that that we have key points for a parent function. We have 3 key points. Okay, so you are going to use this table here. On the left, you are going to get the key points. So they are 3. Okay, and the key points here are these three. These are the coordinates of the 3 key points, right? Based on the transformation, you will identify the operations that apply to the coordinates. That is why you have to type 2 main types of transformation, vertical and horizontal. The vertical affects all the y values of these coordinates, and the horizontal affects all the x values of these coordinates. Okay, so the key points are based on the parent function, f of x, which is here. The new points are going to be the point for q of x. All right, and you need to see how these numbers change based on the transformation. Okay, after you identify the transformation, you need to identify how those transformations affect the numbers mathematically. Okay. On the last exercise, you have I think is this, yeah, this is the last one. Okay, on this exercise, you have all the listed steps, or the step that you need to follow in order to solve any transformation problem. The first thing that you will do, ignore this for a moment. The first thing that you need to do is to identify the parent function, then the transformations. After the transformations, you need to see what operation applies to the x coordinate and what operation applies to the x coordinates. And then to graph, you need to use key points. Okay, so here, since we are working with a graph and not an equation, things change a little bit, but we can get the key point from that graph. So you need to label here, you are going to label 5 points. Okay, so you will have 5 key points and 5 new key points, and then you will do the graph. Because here, this graph represents a function that is not included on the library of parent function. Now, the function that we are working with is going to be different, and in this case we don't have like a particular or a unique equation. There's no equation for this function. The only thing that we have is just a graph, but we can still do our work. How are we going to do that? You will see that this function is represented with f of x. The only thing that we know of this function is its name, f of x. Now, you go here and you will see a function p of x that depends on f of x, all right? And you are going to compare, or you are going to identify everything that is new on f of x. For example, let me highlight those. We are seeing a negative in front of f of x, or f, right? We are seeing that the input now, what is within the parentheses of the function has now a 3. Okay, so it's 3x. So there's a factor that being multiplied times x. So what is the effect on that? And we are seeing a +1. Okay, so we have 3 things that are new to the function f of x. And based on that, you are going to identify the transformations. For the key points, how are you going to identify the key points on this graph? Because this graph it is made up based on lines. See, we can break it down into 1, 2, 3, 4 lines. The key points are all the ends of those lines or segments. Okay, so for example, the first key point here is going to be -6, 0. The other one is going to be -3, 3. This one here is located at the origin, so it's going to be 0, 0. Number 4 is going to be 1 and 1, and the last one is going to be 3 and negative 1. 1, 2, 3, 4, 5. 5 key points. Okay? For the last part here, where you need to graph the new transformation, the new graph, the graph of P of X, you need to label 5 points. Okay, so you need to use 5 points, 5 key points and 5 new key points. You are not going to sketch the graph of f of x here. The one that you are going to be working is just P of X. Okay, in this space, what you are going to do is to take those key points. Okay, you are going to list down here the key points, and here you are going to put the new points. Okay, the key points are for f of x, and the new points are for P of X. Those points you are going to use them to sketch the graph. Okay. Again, this is a lot of information. I'm not expecting that you know how to do this right now today. This is, if you haven't watched the video lecture yet, this is the first time that you're seeing this material. So now you know what to expect from unit number 2. Okay, unit number 2 is an important unit for our class. Okay, now what I'm going to do, I'm going to show you how you will work these exercises in Alex. All right. In this exercise, look what we need to do. And I need to stop here for a moment because you need to remember that you need to do written work for the quiz, the assessment, quizzes, tests, and object, right? This one, even though the objective of this exercise is to draw a graph. See, here what we need to do is to draw a graph. There are steps in between, or there are information that you need to present, or there are information that you need to get before completing the exercise. Okay, to draw a graph, we need to calculate, or we need to get some points. How are we going to get those points? That is the part where you are going to do your written work. Okay, if you just draw a graph and do not show supporting work for this type of exercise, you are not going to get credit for it. Okay, even it doesn't matter if the graph is correct or not. You need to show written work for this type of exercise. Okay, and you will see how you will get that written work. Okay, this exercise is basically this type of exercise where we have a graph. We need to identify some key points. We will have a new graph based on what we have. We need to identify the transformations. We need to identify the operations on the coordinates, and then we need to label the key points and the new points. Okay. So we are going to do that first. Okay, so I will just take a screenshot from this so I have more space on a new page. Okay, is this good on your end? All right. So here you are. This is the exercise that you have from Alex, and the first thing that you're getting is the graph of y equal f of x. What does that mean? Okay. This means you need to remember that you can represent a function at least with, or the main method to represent a function are based on a mathematical equation or a graph. Here, well, we have a function that is, the function is f of x. Okay, this is how we named functions. A letter and then two letters. One will be the name. The name is f. This is f, and the input of that function x. All right, f of x. That's our function. Now, and the only thing that we have is graph. We don't have an equation. I'm going to go for it. This term or this notation here, it is being used. Y equal f of x. It seems trivial, but it is being used because then later we are going to create a new graph based on f, but with some transformations. Okay, so that is the reason why y equal f of x here is being used, is because we are referring specifically to the graph. Okay, and f of x is being the parent function for this exercise. Okay, so in order to draw this function here, or to draw this graph, y equal to f of x plus 3, okay, we are going to go through several steps. All right, so the function of this exercise is f of x. The new function and I'm going to use a different color for the new function so we can identify it. Let's do this one. And to be consistent with the exercise, I'm going to use y equal f of x. All right, so the function or the parent function of our exercise is f of x. Then the new function is going to be 2 f of x plus 3. Okay, so very important to know this because this is going to lead us to find the correct answer. Okay, so our objective here is to draw this graph, the graph for the purple equation. So let's identify first. The first thing that we are going to do is to identify transformations. Okay, that's for step number 1. And this is what you are going to do in your written work to solve this exercise. Transformations. How are we going to identify those transformations? We don't need to go and we don't need to look at the graph. What we need to do is to identify differences. We need to identify differences. And I'm going to go and copy these two equations here just to compare them. And please tell me on the chat what are those differences. What you are seeing that is different from one to another one. What are the differences here? Okay, Amanda, 2 and 3. Okay, yes, 2 and 3. I would like you to be more specific. Okay, how 2 it is being used and how is 3 is also being used. Let me explain. We are working with equations. So 2 and 3, yes, are two numbers that are different there, but how are they attached to the equation? For example, 2 is being multiplied times f of x. Okay, the multiplication the mathematical operations are important, because based on the mathematical operation is how we are going to identify the type of transformation that it is. All right. So we have a multiplication, and let me use another color just. So we have a multiplication. Or let me put times 2. Let me see how I can write that. Let me put it this way. Okay, I think we can understand that I'm referring just to the multiplication between 2 and f of x, okay? That dot or that point is multiplication, okay? Let me put it 2 times f of x, okay? And what we want to know is what is going to be the effect on the function, okay? The effect on this function, f of x, because that is the parent function for it. Okay, first thing that we need to know. Everything inside this parenthesis is going to be known as the input group. All right? Everything outside those parentheses is going to be known as the output group. Okay, why is that important? Because we have two main transformations. We have vertical. This is vertical. The word is vertical. Vertical transformation, and we have horizontal transformations. All right. So now since 2 is to answer this on the chat, is 2 in the output group or in the input group? It is on the output. So 2 is on the output. So we know that we have a vertical transformation. Okay, first thing to identify is that the type of transformation that we have. So it's a vertical transformation. Then, what operation is being used here to attach 2 to f of x? We have a multiplication by 2. Okay, multiplication by 2. This means a vertical stretch. TACH. Google, help me. How do you write that? Yeah, I did it right. Okay, vertical stretch. So we have a vertical stretch. We have identified the type of transformation that we have here. Okay, so that is the first transformation. Is that clear? Perfect. So we are done with the first one. Then we know that we have a plus 3. The other one is a plus 3. And good question, Amanda. This part here is not, is something that I just put just to show the type of transformation that we have here. But you can omit this. If you need to answer or to identify transformations, just vertical stretch. It will be, let me see how you write it. You should write it as, okay, let me go back because Amanda made a very good question. What is going to be the final solution here? Identifying the solution. It will be a vertical stretch by a factor of 2. Okay, so that will be the answer, or that will be the first transformation. Okay, so remember that we have multiples, we are going to have layers for this type of exercise. So identify the transformation. All this here, you can omit all this. All this but our final solution. Okay, all this is just an explanation how we reach the solution. But you can omit all this. Does that make sense? Is that clear? All right. Okay. Thank you, Amanda. All right, the next thing that we have is that plus 3. And I'm going to put it on orange because I want you to tell me what type of transformation it will be, or what type or what group is plus 3 belongs to the output group or to the input group. It is output, so we have a second vertical transformation. Okay. So we have a vertical transformation. Okay, and the operation that we have is adding at 3 to f of x. That means a vertical shift SHAIFT. Okay. So vertical shift, right? Again, this is going to be the explanation. What you need to write down will be vertical shift up. I think, does that make sense? Or I think you can, let me rephrase this so we can understand this better. Shift off by vertical shift up by 3 units. Something like that. Okay. You don't need to follow these exact words or this exact order of words. The only thing that you need to put is something that something that when I read your conclusion, I can identify or I will know that you identified correctly the type of transformation that is there. Okay, so again, this part here, you can omit that. That is just an explanation. You want to go here, vertical shift up by 3 units. See the words are using. This is important. If we are multiplying, we have a factor. If we are adding or subtracting, we have units. Okay, those keywords are important. That way I know that you are talking about referring to multiplication or addition or subtraction. Okay, so that's the first step. Again, I'm taking more time than it's supposed to be because I want to go through the explanation before going through the actual solution or answer for those. Okay, but you are not going to spend this time just identify the transformations. Okay, once you know how to identify the transformation correctly, it's going to be very quick. Any question with this first step? All right. So second step, it will be, what are the operations? Operations. Operation on X and Y. And we are going to get those operations based on the transformation that we have. In summary, the transformation that we have are, we have a vertical stretch by a factor of 2, and we have a shift up 3 units. Okay, so those are the two transformations that we have here. So how are they going to affect the equation or the x and y coordinates? So here, the vertical stretch by a factor of 2, what we are going to do is we are going to multiply all the y coordinates by 2, right? When we are moving up 3 units, okay, this is up, is vertical, we are going to add all the y coordinates by 3. Okay, so these are the operations that we happen on the y coordinate, but we need to combine both. All the vertical operations are going to be combined. Hence, this is the equation that you are going to use to get the new y coordinates. Okay, and this is the final answer for step number 2, 2y plus 3. Any question on this one? Now, we need to get, if I can move, oh, that's it, all right. I'm going down here. Now we need to get the new points. Okay, so to get the new points, we need key points. Those key points belongs to the parent function, which is y equal f of x. And with that key points, we are going to get the new points. And the equation for the new points are, it is y equal f of x plus 3. And it should be consistent. We are going to use the color purple for the new points. Okay, we need to get the key points. So now we need to go back to our graph. And we're going to get those key points. Okay, because we don't have an equation for our parent function, so we cannot identify the we cannot get the key point from the library of functions, the table of library of functions. So we need to use the graph. The graph that we have here have a triangular shape, so we have two lines that are made made up our graph. So we have two segments, segment number 1, segment number 2. How are we going to identify the key points? Well, the endpoint of each segment. Okay, there is one point that connects both segments, and there are two that are the end for the segment. The coordinate for this first point is -2, -4. This one is 0 and 0, and this one is 4 and -2. So here are the key points. -2 from left to right. -2, -4. 0 and 0. And then 4 and -2. So those are the key points. And now we are going to use this equation to get the new points. Okay. So the y values now, the only coordinate that is going to change here is going to be the y values. So we can go and we can put the x coordinate here because there is no horizontal transformation. So they are not going to change. Now, how are we going to get the new y values? So we are going to grab these y values here from the key points, and we are going to plug in those values here on our equation into y. Okay, and based on that, we are going to get those values. Write on the chat what will be these values. Okay, go and use this y value, -4, and plugging in into y into this equation, and tell me what are those numbers. Okay, and see -5. -5, I believe it will be for the first one. 3 and -1. Okay, yeah, -5, 3, and the other one, -1. So -4 times 2 is -8, plus 3, -5. 0, cancel the first term, so 3, -2 times 2, -4, plus 3 is -1. That's correct. Those are the new points. Okay. What we need to do now is to graph, and to do that I'm going to I think I can do it here. Okay, so last step is to draw the graph. So this point will be -2 and -5, I believe is here. Yeah. Then 0 and 3, it will be here. And then the last one it will be -4, +4 and -1. +4, -1 here. All right, so this is the solution. But we are working on Alex, so how are we going to draw in Alex? To draw in Alex, what you are going to do is the following. The first thing that you are going to do is to plot those points. This function, using this function, you are going, when you click here once, you are going to see a new window. And in that window, you are going to enter the coordinates. For example, the first point, -2, -5. You enter those coordinates there, click plot, and then you are going to see a point here. You are going to repeat the same process for each point. You're going to plot all the 3 points first. Then you will use this function, the segment function, to connect the points. And then you are going to submit. On Alex, the solution should look like this. Okay, this is the solution. This is how to look the solution on Alex. All right. Okay, to recap, it is a long explanation of exercise, but you are not going to take this amount of time working with this exercise. Okay, remember that in between the step I made segment for or I take time for explanation of how we get to those solutions. What am I going to look for in this type of exercise? Because you need to do written work. Identify the transformation. You identify the transformation. What you need to write on that step is vertical shift by a factor of 2, vertical shift out by 3 units. Okay, you need to create a phrase or a sentence that makes sense, that I can read. I will know that yes, you identify that transformation correctly. Then, second step, you need to identify the operations that are on X and Y based on the transformations. So if you write this here, 2y plus 3, that is all going to be okay, because you identified that there is just one type of transformation, which is vertical, and this is the equation that you are going to use to get the new y coordinates. Okay, this part here you can omit this because this is the explanation of how we got to the equation. Third step will be key points and new point, and you need to show all this. Okay, you need to show all that. You need to show the key points that you are using, and you need to show the new points before drawing the graph. If you don't need to necessarily show the step to get these values, because I believe this to get those values is very easy to get those values. Plug in -4 and get the value. You can do that in your mind, so you don't need to write for each value all the step of solving this equation. All right, but at least I want to see this table where you identify key points and you identify new points. Lastly, you don't need to draw the graph on the written work because you are going to be submitting that. That's the solution. All right. But keep in mind, you might want to do a sketch of that represents your final solution, because if for some reason Alex received your solution like incorrect, there is a glitch or there is a technical issue with when submitting the solution, At least if I can compare the sketch that you present me in the written word versus what is on Alex, and if what you represent on me to me with your written work, it is correct, I can give you all the credit that you receive, you deserve, okay, that you gain for your work, right? So again, putting the final solution, the graph, in the written work is not going to be, it's not going to be necessary to get all the credits, but at least if you put a representation of the final solution, just in case Alex mess up your final solution, I can check your work and then I can correct anything if needed. Okay, Halima, if the written work, you are going to submit written work for quizzes, tests, and not checked on the final exam. For homework, you are not going to submit the written work. Now, where you are going to submit the written work, I can show you that it is in Blackboard. There is a tab that is named Submit Here. When you click there on Submit Here, you are going to see 3 folders. One for participation, one for the worksheets of the day, and one for the written work. When you click on the written work folder, you are going to see quizzes, tests, knowledge check, and final exam. That is where you are going to submit the written work. I can show you after I finish here the exact location in Blackboard. Okay, so stay after the class so we can go and check that. All right. Second exercise, again, is another type of exercise where the type of exercise is the same. We have a parent function, we need to identify the transformations, and we need to draw the graph. Now, the thing is that in Alex, it's going to be a different way. It's going to be different the way we get to the way we submit our final answer. Okay, so I'm going to solve this. This one is going to be quickly because I already went through all the explanation. I'm just going to solve the exercise. Before I continue, here on the right side, you are going to see on any exercise, you have the tool from Alex. You have a calculator. You have these two. The first one, I believe, is the resource material. So if you want to study the topics, you click on this one. The third one here is a glossary, I believe. And the last one is the most important. If you have a question, for example, let's assume that you are working on this exercise and you have questions about this exercise. You don't need to take a screenshot of this exercise, or you don't need to take a screenshot of this exercise to show me where it is that you have questions. If you click here, you are going to open the message tool or the message window in Alex. There, you are going to write your question, and along with your message, this exercise is going to be attached. So I'm going to receive that on my inbox, and that way I will know exactly on which exercise you are on which exercise you have questions. Okay, so I encourage you to use that tool there whenever you have questions, right? All right. So again, we have a parent function here. It is y equals x squared. You need to know the many ways functions can be represented. The notation of the function here, you see that we are not using f of x, we are just using y equal x squared, but this function is a quadratic function or square function. Okay, on the guided notes you have all the information for this, and now the new function will be y equals 2 times x minus 4 squared plus 3. Okay, so it's the number 1, ID transformations. So to do that, we need to identify the differences between the two equations that we have here. So that is that 2 there, multiplication by 2, that minus 4, and this plus 3. So now we are seeing that we have something within the parentheses. We need to be able to identify the input and the output group. So I'm going to start with the input group. In the input group, I'm seeing a minus 4, okay, a subtraction of 4. A subtraction of 4. Okay, so this is a horizontal shift left or right. X minus 4. Is that going to be, are we going to the left or are we going to the right? Justin, thank you. That is right. Careful with horizontal transformations. They are the logic on the, for my taste, the logic, we are going to use an invert logic for the horizontal transformation. If we see a subtraction, we move to the right. Okay. If we see a addition, we move to the left. Horizontal shift right by 4 units. Yep. Again, keyword here is the word unit. Okay. All right. So now let's go to the output group. So we have only one horizontal transformation. And we are seeing multiplication by 2. 2 times x minus 4. I can drop this. I'm just going to 2 times. What is important is this 2 and the multiplication. Okay. So that is going to be a vertical stretch by a factor of by a factor of 2. Keyword here, factor. Then we have plus 3, and that is going to be shift up by 3 units. Keyword, units. That's the first step. Two, let's identify the operations. I can go from here. Horizontal shift right by 4 units. That means that all x coordinates are going to be added by 4. Careful with that. On the equation we have minus 4, but we are moving to the right. Okay, so if all the x coordinates are going to be added by 4. Okay. Here we have 2 horizontal transformations. We have a vertical stretch by a factor of 2, so 2 times y, and we have a shift up by 3 units, y plus 3. We need to combine these two together to create that equation. It will be 2 times plus 3. So these are the two answers for the second step. The equation for the x coordinates and the equation for the y coordinates. 3. Key point versus new points. We are working with an equation, a square function. So the key points are -1. This is something that you need to know by memory. That's why you are going to use the guided notes, new points, okay, new points belong to that equation. I'm going to copy and paste the equation for each coordinate just to have them as reference. Okay, so we are going to use this equation for the new x coordinate and the new y coordinate. So please write on the chat the coordinate of the new 3 key points. Okay, you need to use the key points. You need to use those equations. Those equations are going to give you the new coordinates. Okay, for example, for the new point, for the first point, you're going to use -1 on this equation for getting the new x coordinate on the first point, and for the y coordinate, you are going to use 2y plus 3. Okay. So calculate those, write the new points on the chat. So I'm getting 3, 5, 4, 3, and 5, 5. Okay. 3, and then 5. Okay. 4 and 3, correct. And then 5 and 5, correct. Those are the new points. Now using those points, we can draw our graph. By this point, we are finished with the reading work. But again, remember that, well, this is if you want, you will draw a representation of the final solution out of the graph, just in case something when something will go wrong with Alex. If something will go wrong with Alex, at least I have a representation of your final solution. Okay, so if we draw this by hand, we need to plot these points, 3 and 5, 4 and 3, and 5 and 5. And this is going to be the new graph here. Now, this is the way I should draw better. This is how we do it by hand, right? And you plot the points. 3, 5, 4, 3, and 5, 5. Okay, the question is, how are we going to do this with Alex, with these tool sets here? So you know that we have a vertical stretch, we have a shift up, and we have a shift to the right. To do shift, you are going to use this one. Okay, so that means that you are going to move, you are going to grab on this point. When you click here on the shift tool, you are going to grab one point on the graph, and then you are going to drag it to the right 4 units, and then you are going to move it up. You're going to move it up 3 units, and that is how you get that point there. But you are not done yet because we have a vertical stretch. Then you need to do a vertical stretch, and this is the tricky part here, because your graph need to align with these points here. Okay, so you need to play with your mouse until you get the right graph. And here is when things can get wrong, very wrong. That is why you want to at least give me something of your or a representation of your final solution, because this is not 100% reliable. All right. So yeah, be careful with this. You need practice. You will get it, but you need to practice how to get that. Okay. The other tools are for reflections, and this one is for horizontal stretch or compression. The final answer, it looks like this. Okay, that's the final answer in Alex. Any questions here?
Amanda had a question. She's so confused about the horizontal shift to the right equals the subtraction, but for the new equation, it's a plus sign.
Oh yeah, thank you, Joseph. Amanda, I'm sorry I missed your question in the chat. Yes, let's go and talk about that. Okay. Let me see how can I give you a better. Let me use Desmos. Okay. I don't know if you can see this well. All right. So we have y equal x squared. That is going to be the parent function. Okay. On red, we have the parent function. Let's do now the new function with other color. Okay. So here we have, I don't know how well you can see this. Let me get rid of that. Okay, on blue is the new function, and red is the parent function. Okay, and we want to explore the effect of that -4 on the input group. Okay, why is it going to the right when we see a -4? And my logic tells me that if we are subtracting, we go to the left. Okay, so let me create a new equation. Let me hide this for a moment. And let's explore how that changes. Joseph, you are muted. You're muted. Okay. Can I grab this point? Yes. Is this good on your end? I think I can put this like better. Maybe -2. No. Maybe -3 and 3. And maybe this is going to be -5. What happened here? Okay. I want you to focus on this equation. The equation that I writing is y equals x plus a, all that to the power of 2. So we have a square function here. Okay, and we want to explore what happens if a is negative or if a is positive. Okay, what is the effect on the graph? Here on this slider here below, we have the value for the value of a, the variable a here. And we want to know what happened to what place go the graph if a becomes positive. Okay, see the effect that now when a becomes positive, the graph moves to the right. When a goes and when a becomes positive, the graph moves to the left. Sorry, when a becomes positive, the graph moves to the left. When a becomes negative, the graph moves to the right. Okay, so the effect, this shows us that when we are adding in the input group, the function moves to the left. In my opinion, it moves to the opposite side of the addition, right? But when we are subtracting, okay, the graph moves to the right. It is not a concept that we grab so easily because for me it is invert logic. Okay? One more time. And let me give you 2 examples, concrete examples. +4, the green one is when we add +4, see that it goes to -4. And the other color, the other one is going to be purple. So you are seeing here 2 graphs. Both are square functions. One has a transformation of +4 in the input group, and that is the green one, and it goes to the left. We are seeing a second graph, the purple one, y equals x minus 4, that has a transformation in the input group, a horizontal shift that goes to the right. And we are seeing that -4 move the purple one 4 units to the right. And we are seeing that the +4 is moving the green one 4 units to the left. Okay? So that is the effect of the transformation when we modify the equation. That is the horizontal effect that we are seeing on the graph, right? We can go deeper and talk about those details, but I want to focus only on the effect on those plus and -4. If we are adding to the input group, we are moving to the left. If we are subtracting to the input in the input group, we are moving to the right. Okay? Amanda, or the class, do you, is that clear? Do you have a question about that? And that is what I want you, that is what I want to answer. Why does the sign change for making the new equations? Okay, for making these equations, okay, why is that we have plus 4 instead of minus 4 when we are creating the equations for the new coordinates? Why do we have here plus 4 and not minus 4? And to answer that is we need to go back to explore these equations, because in our exercise we have a minus 4 here. Okay, in the input group we have a minus 4. When we go back to the effect, a minus 4 means moving to the right. Okay, a minus 4 is moving to the right. We have our graph that moves to the right. Okay, if we are going to compare these two, the red one is the parent function, and the purple one is the one that have a minus 4 in the input group. See that the purple one goes to the right, not to the left, when we have a minus 4. Now, what is the difference? I'm going to focus here. These 2 points we have for the red one 0, 0, and for the purple one we have 4 and 0. Let me take a screenshot of that so we can go and talk about this. Okay. The equation for this graph is y equal x squared, the parent function. The equation for this one is y equals x minus 4 squared. Okay. This key point for the red one, okay, I want you to focus on this point. I'm gonna put it here bigger, 0 and 0, right? And then I'm going to do the same for the purple one. 4 and 0. And since we have a horizontal shift here, there is just a horizontal transformation. Okay, this point move to the right, so there's a horizontal transformation. What is the difference between 0 and 4? Is it positive 4 or negative 4? It is positive. Okay, so that means that the x coordinate need to move 4 units to the right. Hence, we need to add plus 4, all the x coordinate. Does that make sense? Does that answer your question? It is not an easy concept to grasp, and I appreciate your question, because working with horizontal transformations, since it's like an invert logic that we are going to apply, it is difficult to. Okay, glad that I can help you with that. Any other question before we move on? Okay, and again, thank you, Joseph, for reminding me of Amanda's question. Okay, if I, for some reason, I do not see your question, just copy and paste it again on the chat. Sometimes I miss those notifications. Okay. All right. So another type of exercise that you are going to encounter in ALEKS. This type of exercise then is going to test you how much you know about the functions, because there are different properties for the functions, and what we have here are going to be parent functions. We are going to we have parent function on the left column, and what we want to know, what we want to do is to check mark on any property that belongs to that function. Can someone tell me the name of the first function here? If you know it. If you do not know it yet, that's okay. Or can yeah, if you know the name of the first function, you can write that on the chat. I'm going to give you 30 seconds. If not, we are going to move. I'm going to tell you what is the name of that function. Okay, that's okay. You are going to know the name of the function when you watch the video lecture and complete the guided note. Okay, a h of x. The name of the parent function is or the title function that we have here is a square function. How can I get that, or how do I know that? Well, I'm going to look at the equation that is here, and I'm going to look for unique characteristic of the equation that tells me the type of function that it is. This is a square function, or parabola, or quadratic function. Okay, I know that because x squared. Okay, now I need to match these properties, or I need to check these descriptions or properties with my function. Since a square function it is a parabola, I'm not going to have a vertical line is not going to describe that function. Horizontal line is not going to describe my function because a parabola has this shape. Okay, and a parabola could be facing up, or opening up, or opening down. We could have these are the two possible shapes for a parabola: opening up or opening down. Line is not a line, so we can discard these two as well. Now we are seeing parabola opening up, opening down, or parabola opening up. So we need to decide which one is this. You will see that we are going to focus on the first term, and the first term is positive. We have positive 2x squared. That means that there is no reflection over the x-axis, and hence that parabola opens up. Okay, so we discard this one because that parabola does not open down. Okay, and that's how we are going to do this type of exercise. Going to the next one. The next one is a constant function because g of x is equal 4. So it is not a vertical line. It's going to be a line, but it's not going to be vertical. The slope is going to be equal to 0 because it is constant. So it doesn't have a slope. It is not going to be a parabola because it's a constant. And then the one that matches with this function is a horizontal line. It's a constant line. Okay, the graph of this one is just a horizontal line. The last one we have here, x minus 2. That's a line, or that's a linear function, right? Since it has a slope of 1, okay, you need to be able to identify the slope of a linear function. It has a slope of 1. We know that it is a line, but it's not vertical nor horizontal. We have that it has a slope, but now we need to determine between negative or positive. It is not a parabola. The slope here is positive 1, so positive is the one. This one is discarded, and we got this. and then you click submit. For this exercise, you don't need to do written work. You need to check mark on the correct bubbles here. Any question with this one? Okay, this is the last exercise that I'm going to discuss. I have a few more, but are going to be basically a repetition. Well, I think I can do this quickly, so I don't want to take more time than 1.5 hours. Another type of exercise where you don't need to do written work, you just need to select the correct answer on Alex. And again, you are going to use the library function to do this correctly. So you have this graph here, and you need to be able to choose the correct equation for that graph. So this is a linear one, right? Since this is a linear equation, and it's in that it is the identity equation, so if f of x, so it's this one. Okay. Then you are going to click on the second one, and you see that this is a parabola, so it is this one. Third one, we have worked with this one. We have here a V shape, so the equation is f of x, absolute value of x, because it is an absolute function, absolute value function. And the last one, we have here a rational function, and both fragments of the graph are positive, so that means it is this one. Okay, and that way you answer this exercise. Okay, again, but here the way you answer this is using the derivative function. Based on the derivative function, you can identify the equation of those functions. Okay, no written work for this one. Okay, in this exercise, we need to write an equation based on this function. This function is going to be the parent function. Okay, the parent function of this exercise is f of x 3x squared plus 5 plus 8. And here we have the description of the transformation. The graph f is translated vertically downward by 5 units. And now it becomes the function of h of x. We need to find the expression for h of x. So we need to write an equation here. Translated vertically, we know vertically means that we are going to be working with the output group, and it goes downward 5 units. So f of x minus 5. Okay? Then to create the equation, we substitute f of x with 3x squared plus 8 minus 5, and then we simplify, and we got 3x squared plus 3, and this is h of x, and that is what you are going to put here. Any question with this one? This one is very similar to the one that we already did. Okay, so you need to identify the transformations, you need to identify the key points or the operations and the new points. Okay, here we have a plus 5 on the input group. That means, class, this is a question. If we have a plus 5 in the input group, is that effect, what is the effect on the graph? Is that moving to the left or moving to the right? When we have a plus 5 in the input group, Okay, I have 3 left, 1 right. I would like someone to discuss which one is correct, because I see that there's not an agreement here. We have left and right.
I would think it's right because it's in the absolute. It's in the absolute, so I would think, okay, you can go to the right this time. And I would think, since if it's in a parenthesis and it was +5, then you would go to the left.
Okay, I like your explanation. I like that you are looking through the properties of the equation. I like that you identified the absolute value. Okay, when we have questions like that and we have doubt, the best thing that we can do here, because we can check our work with the technology that we have. Let's go to Desmo or to our graphing calculator. Let's see what happens. And let's test that. Okay, so we are going to have x plus 5. And you tell me if what was that movement, left or right? Tell me on the chat. It is left. Okay, Joseph, I like that you notice the absolute value. I like that you try to find an effect of the absolute value upon the transformation. And just when we are working with the absolute value, at the end we are going to get always the positive value of what it is inside the absolute value. But when we are dealing with transformation only, we focus on what are those differences on the equation. We do not focus on the final evaluation, if you will, from the function. Okay, we just focus very specifically. Oh, we have a +5 in the input group. Well, that's a transformation that move the graph 5 units to the left. Okay. Okay, so it is moving to the left. And then we have a -2 in the output group. That means that we go down 5 units. 2 units, sorry, 2 units. So we know that this goes 5 units to the left and 2 units down. Okay? In this exercise, you need to do written work, but this is how you are going to work this exercise. So you are going to I don't know if I can do this here. So you are going to click on the graph. Where did you go? You are going to click on the graph, all right, with your mouse. So you will see that you will be able to draw and drop the graph. So you will go 2 to the left, 2 down, and drop it there. And that is going to be your solution here. See, when you are in Alex, you are going to see this icon, like a hand, and then you are going to click on the graph, and then you are going to move it to the left 5 units and down 2 units, and that will be your final answer. But again, remember to submit it, not for the homework. Okay, I know that is confusing, but for the homework, you don't need to submit written work. You want to practice with the homework how to do the written work, but you don't need to submit written work for the homework. It's for the quizzes, tests, knowledge check, and the final exam is where you are going to do written work. Okay, in the homework, you are going to practice exercises of type of exercises that are similar to the one that you are going to see on those assessments. Okay, so that is why you want to use the homework to practice your written work, but you don't need to submit written work for homework. All right, class, that's it for today. I hope that it helps you to understand, to get a better understanding of what to expect from unit number 2 and to help you to complete unit number 2. Remember that you will watch, but tomorrow is the due date for unit number 2 lecture videos. Okay, so that is the first step. Then you are going to practice with the worksheet today, and then you are going to be doing the homework. So you are going to be doing the homework by this Sunday. If you have questions, please send me an email. Try to send me an email before Friday. Okay, I try to step away from my inbox on the weekends. Okay, you can send me emails on the weekend, but if I receive an email during the weekend, I will answer those on Monday. So that's unit number 2. You are seeing on the calendar that we have our first quiz on next Monday. For that quiz, you will require to submit written work for that quiz. You have 45 minutes to do it. If you have accommodations, don't tell me here. Send me an email with your paperwork so I can give you any accommodation that you need for the assessments. What else? On Monday we are not going to meet here because that day is just for the quiz. So I'm going to give you will have the entire day to work your quiz. You have 45 minutes to do it, but you can start the quiz at any time before. You don't want to start at 11:30 in the night because you are not going to have time to complete it. I believe, Rachel, are 6 questions. Okay, you can refer to the example that I show here because those exercises, it is very likely that you are going to see some kind of similarity with the exercise I have presented here with the one that are in the quiz. Tristan, no Zoom class on Monday because that is a day for the quiz. I'm going to be available to answer just technical questions, but any question regarding the material for unit 1 and 2, I'm not going to answer that until next day, okay, because that day for the quiz. Does that make sense? Any question? All right, so now we are going to do question time. I know that a few of you have questions. If you have questions, stay on the meeting. If not, thank you for being here. Remember to, if you have any questions, make your question before the weekend so I can assist you with your question before Monday. Monday we have quiz number 1. No class meeting, only for technical questions. You need to submit written work for quiz number 1. The quiz is on Alex, Dylan. The quiz is on Alex. In Alex, you should see on the timeline like a quiz is coming, and you should see it, and it will open on Monday. Halima, you are going to do written work. If you have bought the homework notebook, you are going to do the written work there because that is going to help you to follow the structure. Let me show you what I want you to follow. In Blackboard, you have this document. Okay, so written work, basically, this is the paper here, and you are going to put quiz number 1 problem. You are going to number the problem, and then you are going to solve, and your final answer will be circled, right? If there are exercise that does not require written work, you are going to put just a blank space there. You are going to put quiz number 1 and the number of the problem, but you are going to leave a space there, so that way I know that there is no written work required for that exercise. Or if you want to skip an exercise, you can do that as well. Okay, that is going to help me to guide you are going to guide me through your work on the written work, so that way I can grade your work properly. Below this, there are some examples and explanation and you want to refer to the guidance to know what exercise needs written word and what exercise does not need written word. Okay, this is on Blackboard. If you still have questions about this, just let me know. Okay, so Halima, you have the homework notebook. You will see that the homework notebook is like contain like squares on the pages like this, so you are going to follow those squares.
So if we don't have the notebook with the squares, can we just use a blank sheet of paper and just at least have it neat? And we use the Scantron on our phone to send it. Is that fine?
Yeah, that's going to be completely fine. As long as you follow, you give me something that has a logical order that I can read, that's going to be okay. The most important is that you identify the problems and the assessment. Okay.
All right, thank you.
Okay. Yusuf, you can check the homework that is due. What you need to be doing is on the calendar, and the homework that you have that is due on Sunday is unit number 2. Okay, but to reach homework number 2, you want to go first to the lecture video in Esposo and to the worksheet in Blackboard. Yeah, right now we are entering on in question time, so that's what we are going to do. I'm going to stop here the recording because you don't need to watch more than that. So